Yo, welcome to Homework 19, all about rate laws. We'll go through the answers and see how you did. The overall average was a 3 out of 5, so not too bad, not too bad. And alright, question number 1. We're given a reaction, blah, 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 blah. They give us the rate law. According to the rate law for the reaction, an increase in concentration of hydronium ion has what effect on this reaction? You may not have known what hydronium ion was, but I'll tell you it's the H3O plus ion. We'll talk about that when we get to acids, so this guy right here. Right? And so if you increase the concentration of hydronium, hydronium is a reactant. Anytime you increase the concentration of reactant, you're going to speed up the reaction. Well, almost any time, unless it's zeroth order, then it won't. But for this case, hydronium is first order, so it will speed it up. If you make this number bigger, you make the rate bigger, and so the rate of the reaction increases. The equilibrium constant, we'll get to that, so that'll be another week or two yet. Okay. So A. Question number 2. Another reaction, they give us the rate law. That's the same one. What's the order of the reaction with respect to iodide, I minus? This is one of those questions. So you just find I minus in the rate law, and you look for an exponent. There is none, so you assume it's first order, which means it's 1. That's all you had to do. Pretty simple. Too simple, huh? Question number 3. Given a generic rate law, a new experiment is conducted with 2 times 10 negative 3 molar, which is twice as much as it was originally. What will happen to the reaction rate? Okay. Let's see. Well, if we double the concentration of M, that would double the rate. We double the concentration of N, because it's second order and you square it, you would quadruple the rate. So we doubled and quadrupled the rate, which means it's going to octuple, which is number 8 right there. Okay, so number 8. Letter D. Letter D. And then question number 4. People did well on this one. Again, another reaction. They give us a rate law. Everything's in first order. If you double the S2O8 2 minus while keeping I minus the constant, what will happen? The rate should double as well, right? If you double this and keep everything else the same, your answer should be twice as much. So let's look for a double here. There is only one double, and so we're good right here because the rate's directly proportional to S2O8 2 minus. Okay. Let's see. This is talking about rate of reaction because of the stoichiometry. The rate won't, based on the rate law, the rate won't change because of the coefficients in the equation. To talk about rates, you really have to go to the rate law. Now, if it had asked if you measure the rate in terms of, say, SO4 2 minus being formed, then you could do some stoichiometry. But in this case, it looks like they're just talking about the generic rate of the reaction with a given rate law. And then a factor of 4 because it's second order overall. If both things had doubled, then yes, it would be. But because we only doubled 1 and not I minus, then it's just doubled. Okay, next question. Got a reaction. The rate law is giving us that. Second order and first order. By what factor does the rate of reaction change when they're both doubled? Very similar to what we just did. If you double NO2, because it's second order, you're going to quadruple the rate. If you double Cl2, you're going to double the rate. So you put them together and you're going to octuple it. And so that's how we get R8 again. R8. Okay. So watch out for those exponents there. And that was it. Okay. Thanks for watching. If you have any other questions or comments, let me know. Thanks.